Hey all, this here is an addendum to my previous video on domain for students who have already gotten to logarithmic functions. Now, log functions give us a third way to feed a function something and have it break down, produce something that's not in the real numbers. And that is attempting to take the logarithm of either 0 or a negative number. For example, if we feed x equals to 2 into this function, we get log base 2 of 2 cubed minus 8, which equals to log base 2 of 0, which is undefined. We cannot handle it. Or if we put in x equals 1, similar deal. This time we get log base 2 of 1 minus 8, or 1 cubed minus 8, which is 1, equals to log base 2 of minus 7, which for our purposes is not defined because it's not a real number. More generally, if x cubed minus 8 is less than or equal to 0, we get log base 2 of something bad that we can't handle. And this is all the cases where we're going to get something that breaks. So if we solve this inequality out, we get that it is equivalent to x cubed being less than or equal to 8, or x less than or equal to 2. On the number line, if we think 2 is somewhere over here, we're going to omit everything less than or equal to 2 from our domain, so everything to the left, including 2 itself, and keep everything to the right of 2, making sure to omit 2. In interval notation, this equals to 2 on the left endpoint with a parentheses because we're excluding it, and the interval will go all the way off unboundedly. We'll end it with parentheses as is convention. And that is our domain written in interval notation. Let's look at another example. Let's say we've got L of t equals to the natural log of 1 minus t. Notice here that the base to the log doesn't matter at all. Last time it was 2, here it's e. No matter what, can't take the log of a natural number. Or, sorry, can't take the log of a non-positive number. So, our two ways for this to break are the log, as we said before, and the division by 0 right here, or potential division by 0. So let's look at the first one first. We'll assume 1 minus t equals 0 and try to figure out what value of t exactly leads to that error. Now this is equivalent to 1 equals to t, and that's the end of that. We just know that 1 is one of the values that will break for us. Second off, we know that things will break for us if 1 over 1 minus t is less than or equal to 0. Now, your first instinct here might just be to multiply out 1 minus t. And the reason that doesn't work is, number one, when you multiply things into 0, you lose information. And number two, if 1 minus t is negative, that means we have to flip the sign on our inequality. And since we don't know whether it's negative or not, doing that it's not possible to tell whether we need to flip or not, because we'd have to consider either case, whether it's negative, whether it's not. So instead, what you want to notice here is that if 1 minus t is positive, we already established it can't be 0, so we don't have to worry about that. If it's positive, 1 over 1 minus t is a positive number over another positive number, and is thus also positive. or greater than 0. And otherwise, if 1 minus t is less than 0, 1 over 1 minus t is positive, since 1 is positive, over negative, which is less than 0. So this is the case that causes our function to break by putting a negative number into the logarithm.